This is 3.1 quadratic functions. Chapter 3 moves on to something bigger with functions, and specifically section 1 is quadratic functions. You've seen a lot of quadratic functions up at this point, so we're going to talk about it. This is kind of just a reminder lesson, so hopefully it can remind you, and you can even get quicker and better at doing quadratic functions. So first of all, it's a second degree polynomial. So if I have a general formula right here, ax squared plus bx plus 2, notice it's a second degree polynomial. The parabola, it's called a parabola. When you graph this, it makes like a U shape. If a is greater than 0, so in other words the a, if it's positive, then the parabola is going to go up. The low point, the very center low point, is called the vertex, or the minimum if the parabola is going up. If the parabola is going down, the point in the very center, the high point, it's called the vertex. Both of these are called the vertex, but this is called a minimum because it's the lowest point on the parabola. This is called a maximum because it's the highest point on the parabola. All right, so here I want you to get used to this. We've already talked about transformations. I'm comparing it to the parent function. And to do this as a parent function, I want you to be able to describe it without using the calculator. So you should be able to notice what does the 3 do to the parent function. Well, you should know what the parent function looks like. So the parent function looks like this. And what is that 3 going to do to it? Remember, the number on the outside, if it's bigger than 1, it's going to stretch it. And it's going to make it a thinner parabola. So it's going to look like this. It's a thinner parabola. And the same thing with the 1/4. Anything less than 1, a fraction, it's going to make it a wider parabola. And if we did use our calculator, if we check that, notice we have x squared and then 3x squared, so we graph it. Notice the red one that's the first problem right here. That's going to be a thinner parabola. If we plug, this is just check work. So if I go to the second one, 1/4 x squared, and I push graph, notice it's a wider parabola. So just like I said, I want you to be able to recognize it without the calculator. So notice this is plus 5, and so what is that going to do to it? It's going to raise it up. So the parabola is going to look the same. That's the parent function, but it's going to be raised up 5 spots. And again, I can check on the calculator. So on this one right here, notice what does all of this do? This one shifts it 3 to the right. This one shifts it 8 down. This makes it more narrow or skinnier. And this negative inverts it or makes it go down. So basically, if we're going to have a parabola, the parent function looks like that. But this one is going to be 3 to the right, so it's going to go 1, 2, 3. Actually, what you really should do is invert it first. So if you invert it first, it's going to look like that. And it's going to be more narrow, so it's actually going to be like this. It's going to be more narrow. And then it's going to be shifted 3 spaces to the right and 8 down. So way down here, it's going to look like that. So if we went to the calculator, just to check it, so we turn that one off. All right, so if we push graph, notice we have the blue is the original parent function, and then we notice we shifted it 3 to the right, 8 down, and it's more narrow. Okay, so you, again, recognize it without the use of the calculator, because we've already learned transformations. All right, so just so you get used to, this is called standard form. You've seen it before. Matter of fact, we just did a problem like that. So this is called standard form. The HK is the vertex. That's the vertex. So some books or websites, this is called standard form, but some books and websites call this vertex form because it literally tells you the vertex. So that's the cool thing about this. You can literally look at the vertex. It's at 2, 1. I know it. I don't need to use a calculator. It's literally right there and right there. That is the vertex. And that, because that's important, because then I know this is, remember, this is your x, this is your y. This is also, remember, this is also your AOS, your axis of symmetry, at 2. So that tells me a lot of things. That's the center of the parabola at 2, 1. Well, the same thing here. What you need to do is notice the HK, so the vertex is -3, -4. It's always the opposite of this one. Okay, so -3, -4, and of course the axis of symmetry, the AOS, is -3. Again, just recognizing what the vertex is. And again, we're going to get to the A and what does the A do and all that kind of stuff. But specifically, I want you to get used to the standard form. H and K is the vertex. All right, so let's look at this one. Notice this is not in standard form. I want you to be able to write that in standard form. So this is your ax squared plus bx plus c. That's like the generic form of a parabola. And I'm trying to get you to write it in this form. So there are multiple ways to do this, okay? Now, one way we could do this, and notice, I do notice the A is 2. Okay, so that's a nice thing. So I automatically know y equals 2, x minus plus, so that's hk. So all I need to do is find the vertex. Well, one way to do this, and I highly suggest it, because some of you just might quickly grab a calculator, but I'm telling you, sometimes the numbers aren't nice, and it is best to do something first. So I want to remind you to find the axis of symmetry is -b over 2a. So -b in this problem, -b over 2a, that would be -8 over 4, which is -2. So I automatically know the vertex is -2 something, which makes that +2. And then what I can do is I can literally just plug -2 in, because if x equals -2, I can plug -2 into the problem. So if I literally plug -2 into the problem, so notice this, if I know that's the vertex, then I know that's a +2 and then -1. Remember, it's always the opposite of what the x says there. So now I wrote it in standard form. The other way you could do it, if you did use a calculator, again, just type in, let me type that back in. I'm turning all the other graphs off. I'm keeping them there, but I'm just turning them off. All right, if I take the original problem, 2x squared plus 8x plus 7, you could push graph, and then you could find the vertex from -2 just by looking at it, -2, -1. You could also use your calculator to find it, do second trace and then do the minimum. You can do it that way if you want. Find it. So once you find it, you know that. The problem, again, noticing the A is 2, so that's a big clue to be able to help you out with the equation. All right, so how do you write in standard form of a parabola that has vertex 1, 2 and passes through a certain point? Well, notice here, we're trying to get standard form. We're trying to get this. And they already tell me something. They already tell me the vertex is 1, 2. So x minus 1 plus 2. So they told me that. They also told me something else. They told me it has to go through that point. Well, remember, this point is xy, so I'm going to literally replace the x with 3, and I'm going to replace the y with -6. And I'm going to actually solve this problem and solve for a. So 3 minus 1 is 2. 2 squared is 4, so 4a plus 2, which means 4a equals -8. And then that means a equals -2. So now I know what a equals, so then I can x minus 1 plus 2. So my vertex, or my equation in standard form is this right here. Now the way to check it is if I plug that into the calculator, it should have a vertex of 1, 2. So let's actually check it. So if I go to my, let me do it on this one. So if I plug this in, so if I plug this equation in and push graph, notice that on the table it has a vertex of 1, 2. and it also it goes through the point 3, -6. So it's a good way to check it. Just plug it in your calculator and check it as a double check method to be able to do that. Now, let's go through a parabola. Notice this is not, I'm giving it like in the generic form, ax squared plus bx plus c. And I want you to find the vertex, I want you to find the y-intercept, I want you to find the x-intercept, and I want you to write it in standard form. So I want you to do all of that on this problem. All right, so again, there's different ways to do this, but what I would probably first notice that the a is a negative, which means the parabola is going down, which means the vertex is up here, and that is a maximum. So one of the questions is, is it a minimum or a maximum? It is a maximum. To find the vertex, I would suggest, again, is negative b over 2a. Remember, this gives you the AOS. So negative b over 2a, and that's going to give me positive 3. So I know the vertex is 3 something, and then you can just simply plug that in to find the vertex. Okay, so 3, 1 is what you would find once you plug that in. The y-intercept can always be found, again, if you make an xy chart, the y-intercept can be found if you just plug 0 in for x, and that's going to give you -8. So 0, -8 is the y-intercept. All right. All right. To do this next thing, what we're going to do is solve for, well, it says the x-intercept. To find the x-intercept, we're going to put 0 in for y. So if we put this thing in for y, so we're going to put 0 equals negative x squared plus 6x minus 8. I'm going to factor out a negative. Factor x minus 4x. Set this equal to 0. Set this equal to 0. And 4 and 2 are my two intercepts. So 4, 0, 2 are my two x-intercepts. And then it says write in standard form. Well, standard form, if I already know the vertex, which I do, it's 3, 1. Remember, standard form is ax minus h squared plus k. The a, I can see right here, is -1. And then the vertex is 3, 1, so x minus 3 plus 1. You've got to do that. So this right here is standard form. And a good way to check that is if you plug that into your calculator and plug that into the calculator and put your graph, it should be the exact same equation to be able to check it. So that's one way to do it. Notice I found the vertex, the y-intercept, the x-intercept, and I wrote it in standard form. So I quickly want to notice, just point out, different formulas do different things. I highly suggest, again, going through that same process every single time. Because even here, if you start with x equals negative b over 2a, remember this gets you the AOS. And so negative b over 2a is going to get this as the middle of the parabola, the AOS. So I know that this is -3/2. Again, if you use a calculator, it'll give you a -1.5. You've got to do that. And then you can easily, just by doing that little step, you can easily find, when you plug that in, whether using your calculator or just plugging it in, you can find the vertex. You've got to do that. Then you can find your y-intercept, you can find your x-intercept in standard form, just like what you did already beforehand. And remember, I want exact answers on everything. So the decimal approximations, so if you use your calculator, you might end up with a decimal approximation on some of these problems. And I always want the exact answer to be able to do that. So I went ahead and paused the video and filled all of this out. So you probably need to pause the video and practice this, like how did you get the y-intercept, how did you get the x-intercept. So again, I'm not looking for decimal approximations unless I specifically ask for decimal approximations. So here you have to use the quad to find the x-intercepts, and then I put it in standard form. Notice the a is 1 because I noticed the a is 1 right there. There are quickly other problems that we could do. Again, make sure you find the axis of symmetry. That will help you out tremendously. And then even a word problem like this. Find axis of symmetry, and then find it.